All right, so today we're going to spend the entire time from now until 6:19:30. Get that 30 seconds. Talking about serotonin. Okay. So if you're, I don't know, some people have these weird things where like maybe serotonin, just the thought of it makes you want to vomit. This is going to be a rough day. Okay. But if you're okay with serotonin, then we're going to be fine, right, Brad? So we're going to talk about serotonin the whole day. Everything we talk about is going to come right back to serotonin. So what I would do if I were you, I would quickly learn what the abbreviation for serotonin is if you're going to take notes. And that abbreviation is 5-HT. Okay? Why is it 5-HT? There is a word, Dina, that means serotonin. It's about this long. And it's a word that has a 5 at the beginning, believe it or not. And then H and some T's and some Y's and some O's and X's and a few other letters that you don't really need to know. Just know 5-HT is the abbreviation for serotonin, and you're going to be fine with your life. Okay? Does that work? It's an abbreviation for actually the chemical structure and the chemical name for serotonin. So if you see that somewhere, 5-HT, that's what that is. No worries, right? So everybody's solid there. Why did I put the panacea? One, because I think you need to know what the word panacea means. Because how many of you work crossword puzzles? Seriously? Nobody? Like, okay. It's okay. I won't let them make fun of you. We'll wait until you leave. So, panacea is sort of like a cure-all, right? So write that down. That's like a 7-letter word for cure-all. If you ever run across that in a New York, right? So you're making note of that. Why did I say the panacea? So, serotonin is implicated in what kind of behaviors? All. That's a fair answer, right? So, why would we alter someone's serotonin level? Well, it can be for any reason, right? Again, Amanda, let's think, and we don't have to admit to any of this, but I think we all know someone who's on an SSRI, right? And if you don't, it's just because the 8 people you do know, 7 of them haven't told you so, okay? Because SSRIs are fairly common, right? They're fairly commonly prescribed. Lots of folks are on SSRIs, that's cool, right? It's going to affect serotonin levels. We're going to talk a little bit about how that works later, and how we might use SSRIs in an experiment to try to figure out what serotonin actually does. Anybody know a reason why you would prescribe someone an SSRI?
Depression?
Yeah, depression, right? That's a big one. Irritability, that's another one.
Sleep disorders?
Sleep disorders, yeah. Anybody who knows someone who's on an SSRI, number 1 side effect? Sleepiness, right? He's kind of drowsy. That's really great if you're irritable, because if you're asleep, people can't irritate you. Also works the same way for aggression, right? So if somebody's really aggressive, they'll give them an SSRI, try to tone it down a little bit again. It's hard to sleep aggressively. Some people can pull it off, if they kind of flail around while they're asleep, but it's difficult to do. And some of you are thinking like, I actually sleep with someone who sleeps aggressively, and I wake up with bruises. So that's, I don't know if nobody wants to admit to that, because that would probably give you and the rest of the class more information about your social situation than you want to admit, right? So everybody's gonna like. Then you don't really want to say like I sleep alone either, because then everybody's like, wow. So it's one of those questions you're not going to answer, and I know that. I've pigeonholed you there, so that's okay. I think we've all slept with someone, shared a bed with someone, right? I think that's a fair assessment for most people. Even if it was that one time, with your cousin on that weird family vacation. So there you go. Anyway, no, I'm not going to ask that question. I was going to ask a question about why are people like, well, let's do head to foot. It doesn't really change any other parts, does it? I mean, does it? I mean, if you're just like I don't know. There's like a pivot point in the middle that doesn't move. And I don't know that it actually accomplishes anything. So, serotonin, panacea, maybe, right? So maybe we want to think about serotonin as this sort of cure-all for anything that's wrong with you, right? Let's give you a little serotonin. We'll try that first. One of the nice things about SSRIs is they have a fairly tolerable side effect profile, right? Some of the other things we're going to talk about later in the chapters coming up, some of the other monoamines, some of the other neurotransmitters that you might try to tweak if someone's got some problems. The side effects are pretty severe, right? And there can be some severe side effects with SSRIs as well, but they're not as common. All right, so serotonin. Let's talk a little bit about the neurochemistry of serotonin. I'm not going to ask you a lot. You will have to completely, out of pipe cleaners and cotton balls, create the structure of serotonin for the exam. So that's going to be something you're going to have to do. So make sure you've got good pipe cleaner skills. You know I hate pipe cleaner. Do you ever tell you why? The ends, right? They always stab you right in the thumb. Yeah. Also, for those of you that don't know, and this was like a big revelation to me at some point, like, do you know why they're called pipe cleaners? They're actually used to clean pipes, right? It's like the smoking pipes. So that may or may not click with you if you're not like a Sherlock Holmes fan, or you have that weird uncle who smokes a pipe. So it is a monoamine. The monoamines are a broad class of neurotransmitters that are also going to include dopamine, norepinephrine. Epinephrine's kind of the same. This norepinephrine slightly different. So it's this broad class of neurotransmitters. We're going to break that down just a little bit smaller because we're going to call this an indolamine. Okay. Now on the other side, so serotonin is really the only indolamine. The other group are called catecholamines. We'll talk about catecholamines later, so don't get too worked up about that. But that's like dopamine's kind of the big guy over on that side, okay? Most of these serotonin projecting cells come out of the raphe nucleus in the brainstem. If you decide to search this on the internet, I'm just going to give you a heads up here, and you do like a Google image search, you need to use like brain or brainstem, okay? Because there's some other parts of bodies that carry this raphe kind of name, and you may not want those popping up on your phone like while you're showing your grandma something, okay? So just as a heads up there, it's okay if you're talking to your urologist, not so great if you're talking to like, okay, so now we've got it, right? It's near that pivot point. These guys project to everywhere, really. Thalamus. The thalamus is going to be kind of this thing in the middle of your brain. It actually is from the Latin for like hidden chamber. So it's going to be in the middle of your brain, kind of like deep, handles a lot of sensory information, right? Cortex, that's that wrinkly part on the outside that does all the awesome stuff, right? Handles all that higher order processing. Your amygdala, this is going to be sort of important to us in our discussions in this class. The amygdala is responsible for fear reactions. Okay. The hippocampus, which is involved in learning and memory, right? Consolidation of memories. Hypothalamus, which is slightly below the thalamus. This guy's pretty important. We'll talk a lot about sort of hypothalamic function later when we talk about hormones. The main job of the hypothalamus is to tell your pituitary gland to release hormones that tell other parts of your body to release hormones, right? So I know it's kind of like a three-stage process, but if you want to, for example, release estrogen, right, that might be something you want to do at some point in your life, for most of you in this class. Your hypothalamus is going to tell your pituitary gland to tell your ovaries, hey, why don't you squirt out some estrogen, right? If you don't have ovaries, it's the same process for testosterone. And the basal ganglia. That's a whole group of nuclei that are really going to be involved in sort of movement disorders, repetitive movements, learning movements, things like that. So think Parkinson's disease, Huntington's disease, basal ganglia nuclei kind of kick out in both of those situations. How many of you are really, you think like, hey, I actually know a lot of brain regions? Like maybe, Brad, you've had one of my other classes where you had to learn brain regions, right? So for those people who've not had that class, did I leave anything out? Or that's just about everywhere, right? There's not much left. After you sort of, you've got the thalamus, you've got all the cortex, you've got your amygdala, hippocampus, hypothalamus, and basal ganglia, right? And then it actually even projects to other places in the spinal cord. I didn't even put that on there. Right? So there are projections down to the spinal cord. So serotonin should tell you, fairly important. Okay, it's going to do a lot of stuff. It's not a surprise. Okay. Most of the time, it has what we would think of as an inhibitory, but really think about that more of a stabilizing effect. And it kind of modulates other neurotransmitters, right? So serotonin typically, Bree, does not cause an action potential on its own, right? It doesn't cause activity on its own. It's got some sort of, it helps another neurotransmitter, right? Sort of stabilizes those effects. And that makes some sense if you think just sort of what's the behavioral effect of that SSRI, right? It's mood stabilization, right? So we try to think about, well, it's just going to stabilize the effects of those neurotransmitters that make you feel better, right? That make you less aggressive, okay? So it's really going to be more modulating other neurotransmitters. So that's kind of cool. Which could explain why it has to go everywhere, right? Because we have other neurotransmitter systems that are more selective, right? That aren't necessarily going places. And it just gets so we want serotonin to kind of help out in all those places, right? Sort of a booster. It is synthesized from what we call the essential amino acid. You guys know the difference between an essential amino acid and a non-essential amino acid? So what are things that are essential? Try to define that without using the word essential. Because the first thing you're going to say is, well, it's something essential, right? That is something essential. Anybody read Catch-22? Brilliant book. You should spend your time on it. There's this character, Yossarian. Well, what type of a name is Yossarian? What's Yossarian's name? It's sort of a stream of consciousness World War II novel by Joseph Heller. Okay, you should really read it. So tryptophan, it's an essential amino acid. It means it's diet derived. So we have to eat something to get tryptophan, right? So there are a couple ways you can do this. One is like turkey. Who loves turkey? All right, thank you so much. Yeah, right? I mean, your hand's still up. Dina, like other people were just kind of like, yeah, but you were like, no.
I'm hungry.
You're hungry, yeah. I've got a nice loaf of rye bread at home and some turkey. And I'm very excited to stop at the store and buy some smoked Gouda and put that with that rye in that turkey, because that's going to be brilliant.
Sounds great.
It does, doesn't it? I don't know if you're a rye bread fan. I really am. So tryptophan, it comes from your diet. Anybody not eat turkey? Like ever? Like okay. So some other things, I'm really thinking about people who are like vegetarians. Right? So if you're a vegetarian, you have to get sometimes your amino acids from other sources, right? So there are other sort of amino acid sources. You might get some tryptophan from there. We have to get this from our diet. We can't synthesize it inside our bodies, right? Some amino acids we can sort of cobble together from other things, but Kate, the tryptophan, we can't do it. So don't quit cold turkey. Put that in a crossword. Now, there are a couple steps involved in creating serotonin from tryptophan, right? So we've got tryptophan, that's not serotonin. Just in case you want to know, there are a couple steps in between. One of those involves an enzyme called tryptophan hydroxylase. It's like, don't worry about it. But that's actually sort of a rate-limiting step for those of you who are interested in rate-limiting steps. John is. She's like, put a star by that. So rate-limiting steps are the steps that, like, that's the thing that's hard to do, right? That's the thing that's in limited quantity, okay? Not some other part, right? So let's think about this in a way that might make sense to you. I'm going to try to think of something that you try to do every day, or something you make every day. What's a process you go through? How many of you are interested in, I think this is a rate-limiting step here. For example, like overall fitness and weight loss, for example, right? So, Abigail, typically it's not activity levels, typically, right? That's usually not sort of the, like people will go exercise all the time, but it's donuts. That's a rate-limiting step, right? Because it's the dietary side of things, right? That sometimes is. So what's the thing that's kind of puts the bottleneck on the process, right? How many of you have ever been to Beckley? Yeah, a rate-limiting step there might be the toll booth, right? You ever just want to like see what happens? I wouldn't recommend that.
They just sold you a ticket.
Yeah. Have you ever gone through there and not had any money? Yeah, I've done that before. And I was like, I just don't have it. I mean, not that I like didn't have any money at all, but it was all digital, and they don't accept digital money. And I don't mean like Bitcoin. I mean like my debit card. And so I had to show them like my license and registration, and they wrote down on a receipt. And so like every time I went through, I was like, here's my receipt. It's like 3 times I had to.
Go to Florida.
I don't think so.
Florida's terrible.
Yeah, just in general. Not related to tolls.
Like
just
to
in
get,
general.
To get on like some of those ramps, like down in like Disney World, you have to pay.
Oh, that's
so much.
Disney for you.
Yeah.
Like I know in the basement
And
of
they only
Cinderella's
accept
castle,
quarters.
they've got like Walt Disney's head attached to all of these cables, and it's just like controlling the world. Down with Disney.
Clearwater takes pictures of your license plate, like when you go through.
Really?
Yeah.
Yeah. They don't like bill
Wow.
you. They just, I mean, they bill you, but they don't like physical money.
That seems like a more efficient way to do
It
it.
probably is.
Yeah, it probably is. So that'll make it to West Virginia about the time the ocean gets us. It's about the time we'll figure out we can do that, because that's about how far behind we are. Also, speaking of tolls, I used to be really upset driving. I lived in North Carolina for a while, and I have to like come up this way to visit my family, right? And I was really upset always because I was like, every time I would pay like $2, but the road was so horrible. And then I realized they pave it $2 at a time. So as soon as you give that person $2, they hand it over to a guy with a shovel of asphalt, and he pats that down. And that's why the road's so bad. They don't save it up and even get like $10 worth of asphalt. They do it $2 at a time. So in case you want to know why the road is so bad, even though you keep paying it every time you drive on it. But it's nice, you see where your money's going every time. Like, that patch was not there last time I drove through. That's my patch. I paid $2 for it. It's a true story. So tryptophan, we've got to get this from our diet. We do tryptophan hydroxylase. We do another step. And the next thing you know, Katie, we have serotonin. And it's ready to use. So, serotonin is going to be stored in the synaptic vesicle. Don't worry too much about that. It's just like a sac of serotonin. It really is. It's a little small sac. You have a bunch of them. When that brain signal comes down to the end of your cell, your brain cell, right, your neuron, and it says, okay, dump out some serotonin, you do that. Not a big deal. You're going to dump out your serotonin. It's going to activate the serotonin receptor. Okay? Sometimes you'll see that abbreviated like this. Sometimes you'll see like an R or a 1 or a 2, like a subscript. That's usually referring, so you know when you see this, right, that's usually referring to a receptor's type. And there are different types of receptors. We'll talk about that in a moment. So we've got to activate that serotonin receptor. Now, We do not, for the most part, want serotonin out there indefinitely, right? Because if serotonin is at your synapse forever, guess what happens to you? Well, you probably just fall asleep. And that's going to be a bad thing if you're juggling flaming chainsaws, right? You want to stay awake for that, okay? So we have a thing called the serotonin transporter that will do an awesome process called reuptake. And the reuptake process will end the effect of serotonin. So the transporter reaches out, grabs those molecules of serotonin, and pulls them back. Okay? Alina, it pulls them right back into that cell that released the serotonin. So hang on to that. Guess what we can do with it then? Well, we can release it again, right? I mean, why, it's like putting a string on a quarter and pulling it back out of a vending machine. You can just use it again. That doesn't work, by the way. You'll lose a lot of string. Which adds up, so you should just go ahead and use the quarter, right? At a certain point, the string that you've lost will cost you more than the quarter you would have spent. I think they have catches in there, too. And at Disney, they probably have some guy with, like, he's probably dressed as Mickey Mouse, but has, like, a taser, and you try to cheat him out of quarters. It's the Mouse Mafia. So, serotonin transporter, we're going to pull that back in. Then we can release it again, or we can break it down with this guy called MAO, which is monoamine. Remember that time I told you serotonin was a monoamine. Oxidase, that's the O. Okay. There are two versions of this, which is not terribly important at the moment, but it's going to be more important later. Okay. So you've got your monoamine oxidase that will break down serotonin into its constituent parts. Okay. That sounds pretty cool, right? How many of you, so remember that first time I told you tryptophan hydroxylase, and then I said oxidase, right? So hydroxyl and they're sort of inverse processes, right? So we're just going to break things down. How many of you have ever heard of a monoamine oxidase inhibitor? It's an MAOI, right? Okay. Sometimes we will give people MAOIs if they have depression or anxiety or a variety of other mental health issues. That would affect the function of this particular enzyme, maybe. It would break down that enzyme, okay, or prevent that enzyme from doing its thing. So it's going to inhibit that process. That would leave you more monoamines in general, right, in that case. And again, remember, monoamines are not just serotonin, it also includes dopamine.
So does the MAO, does it just break down what's left behind after reuptake?
Yeah, so once you've done that reuptake process, whatever you don't package to release again, you'll break down with MAO.
Is that to keep like a gradient or anything?
I'm sorry?
Is that to keep like a chemical gradient or anything, or is that just to like...
Well, some of these things get damaged. Sometimes you have too much, so you can break down the excess and then just create it again.
Are you saying it's like energy inefficient?
Possibly.
Like there's a reason behind it?
But this is a process that you really don't. If you're gonna, what's more inefficient would be releasing screwed up serotonin that's not going to be effective on the receptor, because this is there's a very tight tolerance there for the shape of the molecule that's going to open the receptor in the channel downstream. So you don't care to invest a little extra to make sure this process is perfect. Questions about that? That's not too bad, right? Okay. Brad, how are you doing over there? You ready? There's a slide just for you that I created, and when I created that slide, I said, this is the slide where I'm going to stop, and I'm going to, not this slide. in the future. I'm good because, yeah, this slide, it's important. We're going to talk about it. And there's a sentence, and I'm going to say, Brad, what do you think about this?
Okay.
So be ready.
Okay, ready.
So I'm going to put you on the spot. All right. Now, if serotonin is related to behavior, and we're just going to assume that's true, how do we measure it? And the it in this case, I mean serotonin. How we measure behavior, we can operationally define behavior as well, right? Okay. So if we do want to think for a moment about aggressive behaviors, well, we'll do that in a moment. So we'll think about that later. Let's stick with measuring serotonin levels. Now, where did we say serotonin was being released? It's in your brain. Okay, so there you go. How many of you have ever measured something in your brain? Yeah, I'm going to assume none of you have, right? I mean, that's just my assumption. And the reason I'm going to assume that is because it's a very invasive process, okay? It's going to require, like, drilling a hole in your head. Not a lot of people signing up for that. I'm going to have to, and I'm only going to be able to measure from a very small sort of area, but I could stick, like, a probe in there, right? And we could do this thing called, like, cyclic voltammetry, right? Which is, Dina's excited about cyclic voltammetry, right? It's kind of cool. Not very practical for humans, okay? So that we have to think of what are other ways that we can measure serotonin levels. Okay? Well, one of them is we could actually measure what's called a metabolite of serotonin. So remember that sort of breakdown process I was telling you about? When we do that breakdown process, we'll get rid of that stuff we don't need. That's not serotonin, okay? And one of those is abbreviated as 5-HIAA. So whenever you see 5-HIAA, whew, that's tough. That's a metabolite of serotonin. It's just serotonin missing a piece, right? Okay, so we're going to measure that. Now guess where this is? It's still in the brain, right? Okay, so we have to measure it from not in the brain. One place we can do this is what's called the cerebrospinal fluid. For those of you that don't know, you've got cerebrospinal fluid in your brain and your spinal cord. Okay? Now, a little difficult to jab a needle in your brain. Your lower back, right? So you can do right into that distal spinal cord, right? You can do a lumbar puncture, okay? And you can just suck out all the CSF you want. If you want the person to live, I would leave a little. If you don't really care, just keep sucking. Sort of up to you. If you had a medical license, you'd probably lose it, just like infinitely drawing CSF from someone. But if you don't have a medical license, you know, what do you got to lose? I mean, probably something. Like they might actually put you in jail for that. So I don't recommend it. But you can draw cerebrospinal fluid from the distal spinal cord. So that sounds awesome, except here are some problems. One, sometimes serotonin is broken down and it's never been used for synaptic transmission. Because you've got it inside your cells, right? Maybe you didn't release it. You're just like, wow, this is kind of old and I need to, you know, get rid of the serotonin I have. The shelf life's bad. How many of you have ever thrown out mayonnaise that you didn't open because you thought the date was bad? Nobody's done that yet, Meredith, because you're not adults. Mark of adulthood, when you read expiration dates, okay? That's a real sign of maturity. And you go, that's even tomorrow and I'm not trying it, okay? Brad, do you do that? I thought so. You seem to be a slightly more mature person in this class. No offense to the rest of you. But I feel like you're someone who would throw out.
I always have since I was little.
Yeah. My wife is like that. Like she's like, that expires this year. We can't buy that. Like, I'm not going to get milk that's good until 2019. Okay? It's not possible. She's like, look in the back. It's like 2 days later. It's not going to make a difference. So, but I don't know. I'm pretty flexible on that. Yogurt, I mean, I don't know that yogurt Embryo is bad until you see mold growing on it. It's good up until then. You can keep it. So, this is a metabolite of serotonin, not necessarily a direct indicator of synaptic activity, right? Okay, so it's not a direct measure of serotonin activity. It's a measure of how much serotonin you had that you broke down. You may or may not have used that. It's also sort of, again, like your brain's up here. Everybody know where your lumbar region is? It's like down a little bit, right? Near that pivot point. So maybe it's diluted a little bit. Okay. Could also be related to this peripheral serotonin, right? So there's also the possibility that serotonin that's not even brain serotonin could be mixing its metabolites in here. Maybe something. Okay. So we're really looking at metabolism and not neurotransmission. However, so don't think all is lost, because this is really the only thing we can do. But what we do find, for the most part, and I'm going to tell you some details later, is that CSF5-HIAA levels are fairly well correlated, inversely, with aggressive behaviors. Okay? So all of the things that you think serotonin should make you do, then if you have high levels of this metabolite, then you're going to be doing those behaviors. If you have low levels of the metabolite, you're not going to be doing as much, right? So it does seem to match up with what we would anticipate behaviorally. So that's okay. How many of you know about prolactin? It's kind of an interesting one. So raise your hand if you think you have prolactin in your body. Okay. Everyone has prolactin in their body. Raise your hand if you think you have prolactin in your body. Still no one. It's like you're not even trusting me. Like I'm telling you, you have prolactin. Okay. Some people have more than others. Like one group of people who might have like a lot of prolactin are breastfeeding mothers, right? And so in case you didn't kind of like figure out from the name, it's related to lactation, right? But it also plays some other roles. A lot of it is related to smooth muscle contraction, right? So that's kind of exciting. If you can think of some other places where you have smooth muscles that you might want to contract at some point in your life. Brad, how much farther do I go with this? Or do I stop there? That's it. That's it, right? So there are other uses for prolactin. That's why some of you who are never going to breastfeed have prolactin, right? Because you have other things that contract, other ducts, right? So there you go. A duct is just really a point where stuff comes out. So think about that. If you think about those times when your prolactin levels might be high, you might think of that. I mean, you shouldn't be like aggressively breastfeeding your child, right? Right? That is not the way to do it. Okay? If you are relaxed, it'll trust me. It'll be a smoother process. Okay? I would ask how many of you were breastfed, but I'll know when you take your exams. And those of you that are laughing are the ones who were breastfed. The rest of you, you didn't get the joke. People who are breastfed tend to have higher IQs. They have more health benefits and things. So if you're going to have kids, which I say please don't, but if you do, breastfeed them. Because they need all the help they can get. I mean, like you've got the choice, right? And baby formula is expensive and it smells bad. I mean, I'm not saying breast milk doesn't smell bad. I don't know or recall, but just like an extra container, right? I mean, you got to carry like extra. I don't know. Just get that cognitive benefit for your kids if you're going to have them. Please don't have kids. Nothing against you personally, Meredith, but please don't. But if you do whatever you can to make them as smart and healthy as possible. Okay. So prolactin levels are going to kind of go up in these times when you're contracting smooth muscle. You should be relaxed, right? least during some phase of this. There's going to be some relaxation involved. So that's fine. If we give folks SSRIs, which would increase their serotonin levels, guess what else goes up? We're talking about prolactin, so that's the other thing that goes up, right? Which makes some sense, right? If your serotonin levels are higher, prolactin levels are going to be high, right? That makes some sense, right? Okay, so they're connected. So we can measure prolactin levels in your blood. That's another way we can do it, right? And we can go, hey, well, your prolactin levels are really high. We're going to assume that your serotonin levels were high. And that means you're probably not, like, punching people, because you're not going to be aggressive. Now I'm thinking about, like, the odd person who is going to subscribe to my channel, who is not, like, in any way in my class. Any of you in my Tuesday class? Nobody's in my Tuesday class? My physio? Yeah, you're in my physio class, right? So there was a great line that I embedded in that particular lecture, and I saw one of the other students in class, or in the gym yesterday, and he said, I wanted my girlfriend to listen to this great line that you embedded, and he said I couldn't find it. And he said I couldn't find it, and so I just had to listen to the whole lecture again until I found it. So he listened to the entire lecture again just for this one line, which was worth putting in there then, right? Because at least one person listened to it. All right, prolactin levels. You're all going to go back and listen for that aggressive breastfeeding story. I don't know. I don't know if I should ask that. So now I wonder, like what am I going to tell you about myself? And maybe it's just like, because I worry about my Google News feed. Have you ever clicked on a story on your Google News feed and you go like, what am I going to get now? Because, like Google's going to think I'm really interested in that. And I do this accidentally sometimes. I'm like trying to scroll, and like I accidentally hit a Kim Kardashian article, and I'm like, I definitely didn't want that. I was just trying to, as fast as I can, past it, because I don't even see why it exists. So I'm like just trying to go on, right? And then I'm like, I'm going to read this article, I don't know, about something else. I see like there are all of these articles now, like I'm seeing things in the news, and I hear about it on TV too, mostly when I'm at the car shop and they're like playing the news, about like people kicking breastfeeding mothers out of places. Is this like a new trend? Like maybe I should have paid attention to that before. Or maybe it just wasn't happening before, I don't know. See, if you didn't have kids, you don't have to worry about this. You don't have to worry about being kicked off an airplane. In mid-flight, they'll do this to you. if you have kids. If I was the pilot. Those kids in the cargo hold with the dogs. I mean, I don't know. People that get on a plane with a baby, there should be a psychologist at the airport when they get off to give them a mental health exam. All right, so those are a couple of SSRIs. We can give those to people, measure their prolactin level. So that's fine. Hey, who's heard of the prefrontal cortex? That's kind of the part before the front, right? So it's like right out there in the front. This is really involved in a lot of sort of like, hey, stupid, don't do that kind of things, right? So it'll really help you think about negative consequences. It helps you think about higher order behaviors and problem solving and other things. It's not the part of your brain, at least we're going to get to a little definition later, so hang in there. But for right now, it's not the part of your brain that makes you want to like strangle people, right? That's another part of your brain that makes you want to do that. And your prefrontal cortex is a part that says, if you do that, you're going to have to drag that body out of the hall. And that's going to be a lot of work. So you could probably just go on and it'd be like an easier day for you. All right, so we can do imaging. So we can do positron emission tomography. That's a PET scan. You can do fMRIs. Not a regular MRI, but an fMRI. Both of these will allow you to measure sort of metabolic activity in particular brain regions. We find that folks with more prefrontal cortex activity, they're less aggressive, they're less impulsive, they tend to do things. This is why have you ever wondered why they give people with ADHD a stimulant? Like, that doesn't make any sense, right? But it does if you think about, like, part of their brain is lazy or part of their brain is not working, right? And that's that prefrontal cortex, right? So if you give someone who has ADHD a stimulant, then that kind of wakes up that frontal cortex and they go, boy, I like really am excited about this, but I'm not going to jump up and yell about it. That seems like a little impulsive. I'm going to, maybe let me think through this process a little more. So that's why you give a stimulant to somebody with ADHD. All right, so we already talked about peripheral serotonin levels. A good bit of your serotonin is made not in your brain. A lot of it's in your gut and so forth and goes different places. So you have to be careful that you're not measuring, like, hey, I'm going to measure serotonin levels in your liver, and then that's not really necessarily going to tell you anything about brain activity, right? How many of you have genes of either kind? The denim kind or the chromosomal? There is some genetic variation in serotonin function. Okay? It's not terribly surprising, right? There's genetic variation in probably just about everything, right? I mean, there are very few things where it's like, well, I mean, there's some things like if you get this, you're alive. If you get the other version, you're dead. And I guess that you may not consider that variation, but there's usually some variation here, right? We call these polymorphisms. And there is actually evidence that there are polymorphisms for presynaptic and postsynaptic activity. So that's going to be things like, for the presynaptic side, we're thinking about the transporter. That's presynaptic. We're thinking about synthesis pathways, maybe. We're thinking about MAO. MAO, right? So monoamine oxidase activity. On the postsynaptic side, we're thinking about receptors and receptor sensitivity and structure and number of receptors, right? The more receptors you have, the more powerful the response to that neurotransmitter. If your receptors are particularly sensitive for some reason, Emily, then they're going to be really excited about just a little bit of serotonin, right? But if they're kind of like, they have high standards, then you have to have more serotonin. All right, questions about this? Like how we might go about measuring serotonin levels if we don't want to cut somebody's head open. Still seems kind of invasive to stab someone in the back, right? To just like drain off a little. Anybody ever had a lumbar puncture? They're not pleasant. I had one once. I broke my toe. It was a good one. I kicked the guy. I tried to kick him in the stomach. I was in a martial arts class, so it was not. It's not like I was like randomly kicking people in the stomach, right? Although I might, but I wasn't in this case. Because if it was like random, I'd have my shoes on. So I didn't have shoes on, right? So I go to kick a guy in the stomach. He raises up his leg. My uncle owned the dojo, and he thought it would be really great if I was like, hey, like the first time I'm there, try to kick this guy who, has been taking classes for 15 years or something. So I thought that'd be funny. And so I kicked him. I kicked him really hard, and he cried. Even though he had a shin pad on like this thick. So I'm glad I didn't kick him in the stomach. Now, like looking back on it, because it really might have hurt. But I broke my toe, and then they had to like stick 2 pins in there to hold the joint in place. But I know. So I told you, Abigail, it was a good one, right? I'm just not gonna splint or tape it up. I'm gonna have to have pins, and then they yanked them out later with a pair of pliers, which was exciting. That was fun. The point is, they stabbed me in the back, because they didn't want to put a tube down my throat to actually, so I went to sleep. So they stabbed me in the back, so I was numb from the waist down for a while they were operating on my toe, which was kind of weird. I mean, I was asleep. I actually did go to sleep while they did it, but they gave me some other anesthetics as well.
I'm curious about the metabolism. So if it's a high level of the 5-HIAA
Yeah.
in the fluid, does that mean it's would be? I'm confused about what effect that has behaviorally.
Yeah, so that would indicate,
high metabolism. Right.
so it's not, you're not, the metabolic rate is not really going to change. You're going to be breaking down serotonin at the same sort of, that's not a rate limiting step, okay? If we have a high number or a high concentration of the metabolites, that would indicate that sort of just prior to that, we dumped a bunch of serotonin out into the synapses. Because some of that's going to get broken down and not go through that reuptake process. So we're going to have extra serotonin more than normal. If your 5-HIAA levels are low, then that's going to indicate that you have low amounts of serotonin. You're not going to be breaking down as much serotonin. Does that make sense? So it's sort of it's a little bit of a delayed response, the metabolites are. Because even though you're going to do this reuptake process, you're also always going to be doing this sort of enzymatic deactivation process as well, right? You're always going to be metabolizing serotonin. And if you have a lot of serotonin, then you're going to have a lot of the metabolites. If you don't have a lot of serotonin, you're not going to have a lot. And so it's really a pretty good way to kind of measure baseline activities, right? Or baseline levels. We're still not going to, unless we're doing cyclic voltammetry, we're not going to get that kind of like instant millisecond by millisecond sort of how much serotonin are we actually using. Okay? So, does that work? All right. Let's talk about some aggression dimensions. And hey, Brad, this is the slide for you because there's a comment from this like chapter 4, and I read it 2 or 3 times. And the first time I just kind of went on, right? And the second time it kind of slowed me up just a little. And then the third time I thought maybe this is a discussion point. Okay, so we'll get there in just a moment.
Ethical aggression.
Ethical aggression. That might be related, so we'll get there. So, what are some ways that we can look at aggression? How does aggression manifest itself? Remember, a lot of these studies are performed in non-human species, right? So, this particular chapter 4 was really focused on non-human primates and humans as well. A lot of aggressive behaviors are in dominance hierarchies. You might even make the argument that this is true in humans as well as in monkeys. And you guys remember those rituals, kind of that ritualistic display, right? Who remembers the crustaceans? And the mural spread, right? And like spread my claws out. Who's got the bigger claws, right? And that's the lobster that's going like, I've got big claws. And the other lobster's like, well, I don't. So I'm going to run away, right? Or scuttle, I guess is the correct term. I'm going to scuttle away. So we have that. In monkeys, we have those dominance hierarchies. There are surprisingly like few fights, right? And that's really smart. Because you don't want to go and, I mean, like if your only way to figure out if you can beat someone is to just walk up to them and start punching them, you're going to lose a lot, right? But if there's like another way you could figure out if you're going to be someone like, wow, he's like taller and heavier than me, I should probably not try this, right? Then that's smart, right? It's also, this is actually what I thought was interesting, leaping. That doesn't necessarily apply to people, this is in monkeys. So they would measure these sort of unprovoked leaps, and monkeys that had longer unprovoked leap. Now a provoked leap is different, right? So if a jaguar is chasing you, you're gonna take your chance, right? What are you gonna do? Certain death at the jaws of that giant feline, or I'm gonna try to jump to that next branch and see if I make it. And that's a different story, right? But if you're just like, I'm just gonna give it a jump for no apparent reason, then that might be indicative of some impulsive behavior, which is going to be related to aggressive behavior, and so we can think about that. And which is really actually kind of cool. So they have this, what they call a long leap ratio. So what percentage of leaps, because monkeys are leaping all the time, right? What percentage of those leaps, Brandon, are long leaps versus regular leaps? Okay. So if that ratio, if there are more long leaps, what they seem to find is that these serotonin metabolite levels are low, right? So they don't have a lot of that serotonin to tell them like, that's probably not a good idea. All right. Brad, I'm going to read this directly from, this is word for word from from the book, and I think this is an interesting sort of concept. They were talking about aggression dimensions. They're talking about ways that we can measure aggression, how aggression may differ across groups. And there was this interesting sort of, they tried to draw a difference between like what monkeys can do that's aggressive and what humans can do that's aggressive. And this really struck me as an interesting sort of phrase. It said only humans can use aggression to commit crimes, enslave others, compel acquiescence to religious or ideological doctrine, or to pursue wars of national interest. And I found that fascinating because I thought, the first thing that got me was the wars of national interest, right? And I thought, well, yeah, people do that all the time. But then I thought, well, monkeys do this all the time. I mean, they don't have like a map like we do, and they didn't name it something after some guy who may or may not have ever been here. Probably already had a name. We just gave it a new one, right? That happens. And I guess the monkeys may do that too, right? Who knows? We don't know. But I thought monkeys, so then I started working backwards. I thought, well, monkeys, they have wars, right, Brad? I mean, what do you think about that? I mean, they're constantly fighting for territory, right? So that they can have these other kinds of things. And so then I took a step back and I thought, well, can they compel acquiescence to religious or ideological doctrine? I don't know. So then I had to think for a moment, like maybe other species, I don't know if they have an ideological doctrine, right, or religious beliefs. There is some evidence in chimpanzees that they do this, that they actually have these sort of rituals. It's like stone throwing, right? They'll throw stones at trees for no apparent reason, which you might find really weird, right? But then if, I don't have to be very careful here, but go ahead, Brad.
Well, I'm thinking of like bonobos, how like they have different relationship structures in different tribes and stuff,
Yeah.
so like
I don't know, right?
that gets murky.
It gets very murky very quickly, right? And people don't like to get into murky things, but I think that's where the fun stuff is. You'll find the most interesting things in the murky water. You didn't know it was there. I'm going to say it's always going to be pleasant. Might be something that bites your finger. But so then I thought, okay, well, what about religious or ideological doctrine? I thought, well, okay, so
Well, weren't we like measuring like crowds and delinquencies? So like,
yeah, right. So we were doing all kinds of things. But then I thought, well, what about committing crimes?
yeah,
That happens all the time in other species, and they punish offenders, right? They don't have them written down on pieces of paper, okay? But they do punish offenders, right? So if you are in another species and you steal something from someone, guess what? Like a monkey will come over and slap you on the head, right? Because you violated one of their rules. So I thought, well, that's wrong too. And I thought, well, what about enslaving others? And I thought, well, maybe that one, right? And then I started thinking about that, and I was like, I think those monkeys probably do that too. And I thought, well, that doesn't make us any different. And then I felt better. So I thought, well, I was right and these guys were wrong, but they got it in a book. So, what do they know? So what do you think, Brad? That's a totally wrong sentence, isn't it?
I think it'd be fun to argue either way, like whether you agree or not.
Just like those great commercials of like people loving pre-shaken soda or like getting their arms stuck in vending machines. Some people like being wrong. That's fine. You're welcome to do that. I don't know. Nobody's gonna venture into this, right? I think it's gonna be fascinating. So what I really thought about with enslaving others, I actually started thinking about infanticide. So you guys know about infanticide? So this is like infant, and then side means to like kill, right? I just turned off the monitor. So what will happen sometimes in gorillas is when the male gorilla takes over a new territory, he will go and kill all of the infant gorillas that are still nursing, right? And he does that for a couple reasons. One, it is why would you want to raise another person's gorilla or another gorilla's gorilla? Is that, I don't know, right? I mean, you wouldn't want to, right? This doesn't seem like something that you're going to spend your time doing. The other thing that does is that will instantly sort of kick those female gorillas back into the like fertile phase of their, we call it estrous cycle in non-humans, but the menstrual cycle, same thing. So it'll kick them over into that, and so then he can impregnate them, and then they can raise his gorilla offspring. So that's sort of like forcing someone else to do your bidding, right? I don't know. Anyway, I thought it was a bad sins and it felt weird in the middle of the whole thing. Because we were talking about like monkeys leaping from trees to trees, and then all of a sudden it's like ideological doctrines. I don't know. It's an odd transition. And then we go right back to men are more aggressive than women. I don't know if anybody found that like shocking. No, nobody did, right? I mean, that's probably, related to serotonin levels, yeah, in some way. Later we're going to talk about hormones, and I think that's going to tell us a better story there, right? When we start talking about testosterone, for example, and aggression, that's a pretty clear-cut story. There are different kinds of aggression, though, right, Brad? You were kind of alluding to this earlier, right? And I don't really want to get into the ethical, because ethical is like, that's debatable, right? I mean, I don't know. You can define that however you want. But in this case, we might want to think about two kinds of aggression. There's what's called instrumental aggression. This is sort of pre-planned aggression, right? This is something that you put some mental effort into. Okay, that's fine. Then there's what we call impulsive or affective, and that's affective with an A, right? So relating to affect or feeling, right? So affective aggression. So kind of this impulsive. So this is just sort of like that random, like all of a sudden you have some emotional outburst and you just like, wail on someone. Okay? Those seem to be like two different things, right? Even though the outcome might be the same, you might be punching someone in the face. One of them might be just like you were randomly walking down the street and you're like, well, that person made me angry and they'd look better with a big fist print on their face. I don't know. And then one of those, Emily, might be more planned, like you and your other log jammers, I don't know. You might go, you know what we really need to do? We need to take out the knees of this other. Do you guys do that? Like,
You have like just sweep the legs.
yeah. So that seems more instrumental, right? That's probably not really related to serotonin levels, because that's a planned strategy, right? Okay. Whereas the impulsive part is a little different, right? So you can still have this obviously within a roller derby bout. You can have an impulsive or effective aggressive sort of outburst, right? Because maybe it's not part of your strategy and you're just like cruising along and all of a sudden you're like, oh jeez, she's got on purple shorts, I don't like that. And you're just like, here's a roller skate to the face. So, I don't know, nobody found that as fascinating as I did, Meredith. I really was, I don't know. You use the four skates, right? You don't do inline?
Quads, yeah.
Yeah, you use quads, yeah. Those are heavy.
They are really heavy.
Questions about the different kinds of aggression? Brad, you look like you've got some. Makes sense though, right? So this is going to be important later because we're going to talk about murderers. Wow, you guys are just... First it was that weird time with your cousin, and then we're going to talk about killing people. So, how many of you are going to call your cousin after this and go, listen, no, nobody's. So, this is going to be important later when we start talking about people. Now, when we're talking about monkeys are monkeys, right? And so, or at least we think so. It's probably not true. But we're going to assume monkeys are monkeys, and then we kind of like, stick everything together. When we get to humans, now this is probably a fairly true statement. The behavioral repertoire of a human is more complicated than that of any other species, right? And I think that's probably a safe bet, even for those people who think their dogs are super awesome. Like you, do you have a dog that's super awesome? It still can't do everything you can, right? You don't know? Does it like flush the toilet? I'm assuming you do that. I don't think that's a huge assumption. I don't think your dog can do that, right? Tie shoes? Tie shoelaces? No, can't do that. So you can respond in other ways. Your dog can like bark and roll over. That's like it's sort of, yeah. I'm sure it's still a great dog though. At least it's not a kid you gotta take care of, it's just a dog. So that's better. So, when we start dealing with humans, it gets a little tricky, right? And we might need to think about things in a different way. So, but I want to set you up with that. All right, here's this thing called LHA. This is kind of interesting. This is a lifetime history of aggression. So there are a number of these psychological instruments, okay, that they're all named after the person who developed it. Because that's what you do, right? So, Lauren, you're going to have the Lauren aggression scale. Okay, you're going to develop this, and then you're going to have this aggression scale. And we can do this. We can ask people, like, how many times have you kicked someone? How many times have you been arrested for physical assault, right? So we can probe someone's lifetime history of aggression and get some kind of idea about their pattern of behavior, right, Katie? And figure out whether this is an aggressive person or not. We have all, even the most relaxed of you out there, have at some point, I assume, committed an aggressive act, right? That's perfectly normal, okay? Somebody, even if it was when you were like 5, and they tried to take your Lunchable, you hit somebody. It happens, right? Elena's like, yeah, still happens. Somebody at your house tried to take your Lunchable still? Yeah, your sister? Okay, look, you should eat Lunchables. They still make those?
Yeah.
Oh, okay.
Convenient.
They're convenient. I guess. I didn't know they still made those. So. But do they still have like the same stuff in them? Like,
Yeah.
Less cookies.
Yeah.
Yeah.
Less
let's go buy a box of cookies. I mean, forget that. It's the only reason to eat the Lunchable. You could eat the cookie first. You know, when your mom pulled the whole thing off the top, I mean, this is fair game. It was all in there. So we can measure lifetime history of aggression. That's fine. Hey, how many of you have ever heard of psychopathologies? Yeah, how many of you are psych majors? How many of you are not psych majors? Okay, that's fine. I could have asked, like, how many of you are gonna? No, I'm not gonna do that because that's not gonna be. Like, how many of you are gonna be able to get a job, and how many of you aren't? Bree, you would raise your hand so that you can because you're not a psych major. But everybody else is going to be like, oh man, I hadn't thought about that. Bree, what is your major?
Respiratory therapy.
Yeah, that's an employable thing. That really is. Because people need to breathe. And even people who, like everybody realizes they have to breathe. Not everybody realizes they need to see someone about their mental problems. But everybody realizes, like, I'm wheezing, I gotta go see someone. That one's obvious. And you live in a state full of wheezers. I mean, that's pretty true, right? Heads up, folks, West Virginia is not the healthiest state in the Union. It's not even, are you all right, Emily?
No, I was just really taken back.
Yeah, I know.
I didn't know that.
It's not even the healthiest state with Virginia in it.
Oh man.
In the title. You know, there's even a healthier Virginia. So you got to worry about that. It's okay. You guys are gonna be fine. Hang in there. You got no other choice. Psychopathologies. What are psychopathologies? Who's heard of borderline personality disorder? Those people are a little aggressive. How many of you have heard of, I don't know, what's another one? Oppositional defiant something or other. I don't know. I looked at a DSM one time, like from afar, so I don't really know what's in there. There are psychopathologies that are in there. Many of them, aggression is a sort of hallmark, is it symptom, sign, indicator, thing that happens, right? Okay. So impulsivity and aggression, they're sort of in there with a lot of psychopathologies. So you guys are interested in that, right? So there you go. Any questions about that? I'm just going to do this. I still thought that was a weird sentence and didn't really work.
Do you ever like just keep the drawings and get rid of all the words and just kind of look through your slides?
I don't.
I feel like it look, like a masterpiece kind of.
Put them all together and make a
Yeah.
Yeah, you guys should
Mosaic.
work on that. All right, let's think about monkeys. That's the title. So we should do that. There are different kinds of monkeys, and a number of them have been studied for years, for a variety of reasons, aggression being one of them. Probably the number one studied monkey of all time is the Rhesus monkey, sometimes called the Rhesus macaque. You know it's been studied for a lot of stuff. How many of you have an RH factor? That's everybody. Okay. If you have blood, how many of you have blood? Right. You have an RH factor then, right? Yeah. And that's really important, not for anybody in here because you're definitely not having kids, but for those other idiots who are going to have kids, that can be an important thing, right? If the RH factors don't really match up, and then the mother's like uterus tries to eat the child, so you don't want to risk that. You have to get shots, but they're really painful, and they make your hair fall out and your teeth turn green. I don't think any of that happens. I don't. I'm just trying to discourage you from everyone from having children. You know what I like? I like space, and I don't mean like. I mean I like space like outer space, but I also like space like around me. And the more people we have, the less space I have around me. And so that's the commodity I'm trying to protect. Right, Chelsea? Just keep that in mind. All right. So Rhesus monkeys. There are Rhesus monkeys in South Carolina. That's not a, I don't know. There's actually an island off the coast of South Carolina that have some monkeys there. They're just kind of roaming around, free for alling, which is fine. They monitor that. But what's cool is this is a colony. This is a fairly naturalistic colony, except they're in South Carolina. So they're that's kind of weird, huh?
Is it plus trip?
Yeah, I know, right? Yeah, I don't know. That's going to cost a lot. And I don't want to be responsible for you. Not you, but that's you plural. That's the plural you. Because I think there's some paperwork I have to fill out. If you want on your own to go visit the monkeys in South Carolina, that's fine. I'm just waiting on one of them to invent a boat. right? And then just like paddle ashore with his monkey family, and then we have monkeys on the mainland. That's going to be something. Actually, so I did my postdoctoral work at Wake Forest School of Medicine, which is in North Carolina, and they have a primate facility there. And they had a monkey get loose. And no, true story. It ran around town for a while, and there were people, like idiots. There were idiots who would like, they were on the news, and they would like sit outside with like dart guns and bananas to try to like catch this monkey that was loose. And I thought that was stupid, because for those of you that don't know, monkeys carry nasty diseases. And if one of them like does anything to you, it's like if you get scratched by a monkey, it's like a real event. And you have to, I mean, there's like, because you can pick up serious disease, seriously, you can pick up serious diseases from monkeys. And so it's like really severe. But these idiots, they were just out there like, man, I'm gonna sit out here with my kid. They were sitting out there with their kids. Those are the, right? This is why I tell you don't have kids.
What year was this?
I was there like, well, I started here in 15, so I was there from 2011. It's probably around 2012, 2013.
I'm from Winston-Salem.
Oh, really?
Yeah.
I lived down there
You
about
are?
3 years. I lived down there like 3 years working at the med school. And were you there when did you know about the monkey? Yeah.
Yeah, it's like right by 421.
Huh?
40.
Oh, yeah. How do you let a monkey out? I hope no one in your family was like that person, because I sort of were they?
No, we don't.
Huh?
No.
Okay. I sort of sincerely hope they lost their job. Because, the last thing we want is people letting monkeys out. Like it's fine if you're like going to take the monkey back to its monkey home. I don't care, that's fine. But don't it doesn't need to be out in a although, I don't know. If you gave it, that's not a polite thing to say. I was going to say if I gave everybody a disease and they died, I'd have more space around. Because I'm smart enough to not try to catch a monkey. I think it was a female.
Were you there whenever the woman had the chimpanzee in her glass room, sunroom?
I think
She was doing studies on it in her house.
I don't think I was there then. Chimpanzees, don't mess with those things. They've got big teeth. Seriously, and they're violent. Not their teeth, like the whole chimpanzee. They use their teeth violently. They do. And they're as strong as 10 million people. They are super strong, actually. And they're super smart. Because they're apes. They don't have tails. They traded in the tail for more brain. They'll plan murders. Did you know this? Chimpanzees will plan murders of other chimpanzees, in the wild. They'll huddle together and, no, seriously, they do this. They'll huddle together for a while and then and then they'll sneak up and ambush another chimpanzee and kill them.
Aren't they the most like humans though?
Have you ever ambushed? Don't answer that. Don't answer that. All right, let's talk about Rhesus monkeys. Even the ones in South Carolina. This was actually kind of interesting, though. Remember that time I told you about all those threat gestures to kind of keep other monkeys from fighting and maintain these dominance hierarchies, right? So what's really interesting, Abigail, is that's not actually correlated with serotonin levels. So these sort of low-level threat gestures are not really correlated with serotonin levels, at least serotonin metabolite. So we'll assume serotonin levels. So hopefully you believe me on this. That 5-HIAA and serotonin we can think about those kind of indicative of each other. So these low-level, these things that you might think monkeys yelling at each other, showing their teeth, kind of threatening displays, not related to serotonin levels. We do know that long leaps are correlated with serotonin levels, though. We talked about that long leap ratio, so that was kind of exciting. So the longer leaps lower serotonin levels, right? So they're going to be more impulsive, more aggressive. Male monkeys that have low serotonin levels have fewer social companions. That their ability to interact in a social situation is really sort of screwed up, right? Okay, so they really are I don't want to use the word awkward. They're unskilled socially, right? They're very unskilled socially. They do not groom other monkeys as often as monkeys with higher serotonin levels. So that's kind of like a thing that monkeys will do. Instead of hanging out and watching a movie, they'll hang out and pick lice off each other. So that's what monkeys do. So that's exciting, right? So pick dead skin flakes, dig through other monkey fur. They have fewer social companions. This can be a real problem for a lot of reasons, because you need that social network, right, sort of survive. You need the social network to make certain that you've got support and resources. Okay, so they're not going to have that. Interestingly, mating season sort of changes things, at least for aggression. When it comes to mating season, serotonin levels don't seem to be correlated with aggressive behavior. Okay, so male monkeys, and this is in male monkeys, we're thinking about low or high serotonin. Their aggression levels are kind of the same during the mating season, right? So it kind of switches things up a little bit, which is really interesting if you think about this, because this is sort of contextual, right? So there's a context here that's important. It's important whether or not it's mating season or not mating season, right? And that's going to determine your behavior. So it's not like this is like a guaranteed story. Like low serotonin, you're always going to be aggressive. High serotonin, you're always going to be relaxed. Okay? Because at least for monkeys, this context of mating season or not mating season seems to change it. And that's for male monkeys. We only really looked at male monkeys there. Remember some of the things we said that were important resources, right? So we want to think about like food, and then sex partners, right? So those are things that will typically induce fights in most species. What's really kind of interesting about this is that's not the only context that matters to these monkeys. For females, what's kind of interesting is captivity versus free roaming females. Free roaming females are more aggressive than captive females. So if you have some captive females and you stick another female in there, well, all's fine. If you have females sort of out and about on that island in South Carolina, trying to enjoy the beach, and you let another female sort of in there, then there are going to be some aggressive interactions. And I think a lot of that is related to like food and territory, right? So if you think about this, if you're in a small cage, you're always getting the same amount of food every day, right? You're not having to forage for that. It's like, there it is, unlimited supply. No reason to be aggressive, right? There's nothing to really fight for there, okay? But if you're out free in this territory, well, some parts of the territory are going to be better than others. And there are going to be better food access opportunities in certain locations. So that's kind of interesting. So there's that other sort of context for this species. Also, it's stable over time. So if they measure juvenile monkeys and they have low serotonin levels and they're making all of these giant leaps, then when they get to be adults, it's kind of the same thing, right? They're going to have low serotonin levels and they're going to be trying to jump things they can't. There are a number of studies that have examined serotonin levels and sort of survival rates in monkeys. And here is not a shocker. Low serotonin, high mortality rate, right? So you're going to die. Probably because you're going to try to do something, you're going to try to jump too far, you're going to fall to your death. So watch out for that. Maybe you try to attack someone who's bigger than you, and they just, smash your head. You don't think about those things. Any questions about rhesus monkeys? So we've got two other kinds of monkeys to talk about, briefly. And then we've got an ape we're going to talk about too. All right, what about vervets? That's another kind of monkey. Pretty much the story lines up the same, right? So nothing drastically different. What was interesting in these vervet studies, they haven't done as many as they have with macaques. They did a process where they did tryptophan depletion, and they did this by eliminating tryptophan in the food source for these vervet monkeys. And what they found was, when this happened, their aggression increased. Okay, because remember, tryptophan is this precursor to that, it's that essential amino acid that's precursor. So if you don't have that, you can't make serotonin. If you can't make serotonin, you've got low serotonin. The story I've been telling you, hopefully that you've caught on, is low serotonin, you're going to be more aggressive, right? They also sort of did the inverse. When they increase tryptophan levels in the diet, then you see a decrease in aggression, right? So what I think would be interesting is if we did a longitudinal study of Thanksgiving dinners and plotted fights. Because, I mean, how many of you have been to a Thanksgiving dinner with your family and there's been an argument or a fight? That happens, right? It's a regular occurrence. But what I want to know is how many of those happen before turkey and how many of them happen after turkey, right? And so, and I want to see if it's kind of the same story in humans. My hypothesis is post-turkey there's a lot of making up, and pre-turkey there's a lot of like strangling.
What about all the Black Friday fights though?
You've already flushed all that out of your system. It's the day later. You got to eat some leftovers before you go in. That, Dina, is instrumental. You planned that. That is a shopping offensive campaign that you planned. So that's going to go in the different category, right, Brad? The same people who go shopping on like those times are the same people who were out there with their kids trying to catch that monkey with the banana. The not so bright. A few years ago, a very brilliant person invented something called the internet, and then another really brilliant person invented something called online shopping. And the great thing about online shopping is you don't have to be around other people to do it. The downside is you don't really get to see what you buy. Okay, so there's a trade-off. But consider it next time. Does that help? There's another species of monkey. We're not going to talk much about it. Very similar results to the other monkeys, but they used that SSRI to do some of their studies instead of the tryptophan depletion. Very interesting. All right. So, hey, look at that. That's the last slide. I know, right? How many other people do you know can do like 2.5 hours with like 4 slides? It's difficult. Trust me. You don't see it very often. They're very dense, right? They're very dense and all these little side stories. I really wanted to tell you, Abigail, the story about my Jason Kidd shoes when I told you about the time I kicked the guy in the shin. But I don't know that everybody in this class would appreciate the Jason Kidd shoes because, you know, he's not as relevant in the shoe market now as he was like in the late 90s. So there you go. I bought a brand new pair of shoes and then I broke my toe like 2 weeks later. So I just wore my old shoe on one foot. So I wasn't going to wear out like one of my new shoe, right? But the day I got the pins pulled out, they told me I'd still have to walk on crutches for a couple weeks after they pulled the pins out. But I had in the floorboards of the car my new shoes. I was like, these are going on me today. I don't care what happens. They were really cool. They had this like iridescent egg on the side. I was very excited about this. All right, so what about you? Who cares about monkeys, right? We're more interested in apes. Okay, so let's think about us. Serotonin metabolism is negatively correlated with lifetime history of aggression. So what we mean by that is the more serotonin you have, the fewer aggressive behaviors you've had. Okay? So if you're pretty high on the serotonin level, you've probably not been arrested for assault. Kind of make that guess. Not exactly true. We can do that. Suicidal behavior also negatively correlated with serotonin levels. Okay? So So individuals with low serotonin are more likely to have attempted suicide in their lifetime. That's not, again, not surprising. I've kind of walked you through this whole story like all day, right? And that was kind of the point. Hey, who knows about recidivism? This is when you do something, yeah. So Brooke, it's when you do something wrong and we put you in jail, and then we let you out, and then you do the same thing again, so you go back to jail, right? So you just keep doing the same thing. Like you didn't get, huh?
Very common in our country.
It is very common. Recidivism is very common. Actually, recidivism is related and correlated negatively with serotonin levels. Right? Sometimes somebody with a high level of serotonin is going to do something wrong. We're going to put them in jail. Probably not going back to jail. If you've got lower serotonin levels, you're more likely to end up in jail again or in prison. That's kind of interesting, right? I thought it was interesting anyway. What's interesting about this is, now we're going to talk about killing people. Yes, serotonin is negatively correlated with lifetime history of aggression, but maybe not for murderers. So when you get to humans, there are a number of conflicting studies that will tell you, yes, serotonin's related, no, serotonin's not related. What's really important when it comes to humans is sample size and the demographics of that sample, right? And things you don't think about when you think about monkeys. You discover a bunch of monkeys. And there are even occasionally some conflicting stories with the monkeys, and we're going to ignore those. So when it comes to murderers, there are a couple ways that you might murder someone. Actually, there are more than a couple ways, but there are a couple sort of broad categories, right? There's the sort of, I planned this out and I just decided to kill somebody, sort of crime and punishment sort of style, right? Where you're like, I think I can kill that old lady and nobody will know. Watch this. Right? I mean, did anybody read that? I only read to the part where they killed the old lady. I didn't read the rest. But I do know they kill an old lady. Like this guy kills an old lady because he thinks he can pull off the perfect crime. That doesn't seem to be impulsive, does it, Brad? That seems to be very instrumental in that. That's a classic example, right? But then there's like the other sort of impulsive sort of thing. Let's think about what that might be. What's a good impulsive? Who's a Shawshank Redemption fan? All right, there we go. A couple hands went up. How many of you don't know what I'm talking about? I'm gonna fail. So Shawshank Redemption, some people say, no, not my favorite or best movie created. I have a couple other picks. Arguably, one of the greatest movies ever created. You've got Morgan Freeman giving phenomenal performance. You've also got Tim Robbins giving a phenomenal performance. They're kind of the lead characters in this. Anyway, Tim Robbins' character is accused of murdering his wife. While his wife was having an affair, he walked in apparently on. Don't want to give too much away, right? So I'm just going to leave it at that. But like killing someone, like let's say you go home and you're anticipating only one person in your bed, but there are two people in your bed. Killing one or both of those people might be an impulsive murder, right? That happens. You're laughing, but those crimes of passion, right? That seems to be a very impulsive or effective sort of behavior, right? Or aggression. Different than instrumental. Different than, I don't even remember the guy's name in Crime and Punishment who thought he was going to kill an old lady and just get away with it. Completely different, right? Okay. So if we're just putting a bunch of murderers together, and that not physically, Meredith, so relax. If we're just going to put a bunch of murderers together in this sample size, we're going to get some of them who were instrumental killers and some who were impulsive killers, and then it's going to kind of wash out the serotonin story, right? So what we really need to do is just get all of those kind of crimes of passion folks, right? And let's check those for serotonin levels. But I think that's going to be hard to do, right? That doesn't really seem like something they'll let us do. So right here I threw out this big confounded, right? But I thought that was funny, but no one else did. AJ, I worked on that joke for 30 seconds. probably when I spent 45 minutes making these slides today. So many confounding variables when it comes to humans, right? And when you get these conflicting stories from research, it's really important to look at who did they check, right? What else is going on? Quite often we're dealing with comorbidity issues, right? Abigail, how do I pull out the people? How do I find a murderer who doesn't have another mental health issue? Because I only want murderers who don't have mental health issues, right? So when I do my analysis, I'm not figuring out whether or not this person, I mean, maybe they're borderline personality. Maybe they have some other issue, right? Maybe they have other things going on that can confound my results, right? I only want murderers with no comorbidity. I feel like that's going to be a short list, right? I feel like that's going to be difficult for me to screen for that. And there are going to be some people slide in, right? So it's going to confound my studies and it's going to be difficult. But what we can do is kind of look at the broad body of work on this, right? And not try to look at a particular study and use that as, so there was, this will happen sometime. How many of you love Neil deGrasse Tyson? I mean, who doesn't, right? And if you don't, I'm going to fail you. He really ripped a guy once, not long ago, because the guy tried to, there was like one study, and the entire time anybody has ever studied the link between HIV and AIDS, there is one study that said, maybe it's not a direct link. One study out of decades of research, okay? Thousands upon thousands, there's one that said, maybe not. One. That the data came out that way, right? Not surprising that there's one, right? I mean, that's not surprising, right? Some guy was trying to ask Neil deGrasse Tyson about it, and I believe his comment was, we don't just make shit up. It's time for you to move on. And so I think we should take the same approach here, Dina, with serotonin, right? This is the story, and we've had this story for a while, and we know it, so don't worry about it. There aren't many studies with kids. Not a lot of people are letting you stab their kids in the back. I don't know why people are so protective of their kids. I don't understand it, Amanda. I don't. Right?
You don't have kids, do you?
No. I got a cat.
Stick with it.
Yeah, that cat's fine. I've had that cat for 17, 18 years. He's doing well.
You better knock on some wood.
No, he just went to the vet like a week ago. Seriously. He's on some new kidney food because at his advanced age, his kidneys don't work perfectly anymore. He takes a blood pressure pill and he's got to eat this expensive kidney food. But again, he's like 18 or 19 years. I found him like as an adult, so he's 18 plus years old. And as a cat, that's old, right? And he still irritates me every day because all he wants to eat are treats. He loves those little Greenies treats. And so when I run out, I mean, I have to like almost instantly leave and go to Petco and come back because of this, like the whole awful. It is. He's polydactyl though. He's got 6 toes on every foot. It's kind of cool. All right, so not a lot of studies with kids. Well, studies there are with kids, kind of the same story. All right. There are some conflicting reports about kids with ADHD and serotonin levels, and you might think, well, like we've talked about impulsivity and aggression, but they're like, you know, not every kid with ADHD is like aggressive. They just can't sit still or listen to what you're saying for more than 2 seconds. But maybe they're not aggressive, but maybe they are. So how do you know? Nah, you don't. But let's just assume it's the same story. This is actually kind of cool, again with the prolactin. And no pun intended, but it is this cool story about body temperature and receptor agonists. This is kind of cool. So you can give people, remember that time I said there are different sort of receptors for serotonin, right? So we have different kinds. We have like receptor type 1, receptor type 2. I can give you an agonist that will activate one type or another type, and depending on which one I give you, Katie, your body temperature will go up or down. So your body temperature fluctuates with these receptor agonists. I don't know, I thought that was kind of cool. It's another way that we can sort of measure if your receptors or your serotonin system is working, right? So if I give you receptor 1 agonist and your body temperature doesn't move in the right direction, then I can say, you got a little screwed up serotonin system. That's pretty cool, right, Katie? It's like walk around with a thermometer under your tongue all the time while I'm shooting you with serotonin receptor agonists.
Is that why people get hot when they're angry or something?
I think that's more related to blood flow.
Okay.
That's my guess. Because it's still a receptor, it's still a serotonin receptor, right? So it's still going to be doing the serotonin story, and hopefully like bringing you down a little bit. But sometimes your temperature will go up, depending on, for one agonist, for one receptor, and then the other receptor agonist that will bring your temperature down. So here's another thing that's kind of interesting. Most studies that have been performed, most studies have found that, as we've shown before, prolactin is sort of inversely correlated with impulsivity in men, right? So that prolactin level, if prolactin levels are high, your impulsivity is low. Because remember, prolactin and serotonin are tied together, right? But we haven't really seen that in women. So in females, human females, it seems that maybe that's not the case, right? So maybe serotonin and prolactin either aren't correlated or that's not correlated with aggressive behavior. Now the problem with this is most of these studies, I think you can tell this was a study conducted by a man. And I'm going to say this because this is my interpretation on this, and if I'm wrong, then you don't have to tell me because I do have your grade book. I feel like if I was designing a study, and I'm thinking about like me and my experience, right? So like my day-to-day experience, I'm not really thinking about a menstrual cycle. It's just not a thing that enters into my thoughts until like that week I see a grocery list and I'm like, oh, I gotta buy tampons this week while I'm at the store. So then I think, okay, well, in the other 3 weeks I forget about it. I think if I was going through this process every 28 days, I would think about it more often, right? And is that a fair assumption? And if I was going to think about a study, and I was thinking about maybe hormone levels and aggression and neurotransmitters, I would maybe think it might make a difference where I am in that 28-day cycle, right? That makes some sense. But no, nobody really ever did that in the past. And so all of these, again, it was sort of a washout, right? It's like, well, no, nothing happens. Because half the women are after menopause, and half the women are premenopausal, and half maybe in one, maybe they're in the follicular phase or not in the follicular phase, right? And that changes your hormone levels. It changes your prolactin levels, right? You don't need prolactin really that much after menopause. That'll, kind of had that story.
How's prolactin tied to serotonin again?
So it's sort of a correlate or an like an index, right? So like when serotonin levels, or when prolactin levels go up, serotonin levels are probably up as well. The same things that might cause prolactin levels to be higher would cause serotonin levels to be higher as well. So the same kind of breastfeeding, right, for example, or if you have higher prolactin levels, prolactin and oxytocin are sort of released at the same time. These are things that are affiliative sort of molecules, right, that make you sort of happy to be with someone, not just someone in general, so that sounded kind of bad, but like whoever happens to be there that may have caused those prolactin levels to go up, right? So they're kind of related.
I've heard that a side effect of SSRI is like an inability to orgasm. How is that tied in?
Yeah, well, that's kind of interesting. It's a good question, actually. There's some other things going on. I mean, if your serotonin levels are already sort of high high and you're sleepy, there's probably not as much motivation, right? But I don't really know why that side effect is the...
You'd think it'd be the opposite if prolactin's tied to that.
But all your systems are slowed down all the time.
Yeah. It's kind of interesting. You can tell us next week. That's some homework. So anyway, but I once you do a study with women who are all in the follicular phase, you find that prolactin actually has the same relationship as in males. So once you time everybody up. So that's kind of a good idea, right? I don't know. Things you don't think about, right? That's why I think it was really the guy who designed those studies. Because I think had a female designed that might have been higher on the list of variables, right? So I'm still thinking about the serotonin thing, Montana. That was a good question. Brad, are you looking this up on your phone?
I'm looking at a picture of Cory Booker with a wig on.
Well, thanks for being honest. I'll say that. You think Cory Booker needs a wig?
No, it's like a funny onion
Oh,
thing.
okay. I was thinking, like, I don't know that Cory Booker needs a wig, right? I mean,
I don't think so.
you don't think so. I don't think it's going to influence his ability to go, whether or not he wears a wig, right? But the onion, I'll give you some credit on that. That's fine. Confusing kids. We already talked about kids being confusing. And we talked about that related to the ADHD story, lack of data on kids. So it's kind of hard, back here we said, stable over time. Don't really have that same sort of longitudinal data with kids that we would have with monkeys, right? So maybe we can do this, like if you all have children, try to have twins. And there are ways that you can do this. It's related to spinning and eating Twinkies. Everybody knows that's how that works. It's not true at all. It's going to happen or it's not. I don't know if you try to activate, I don't know, because your ovaries, they fire in alternating turns, right? You know this, right? And so one will fire and then it takes a month off and then the other one fires. But if you get them both to fire at the same time, you get 2 eggs. And again, the eggs are the rate limiting factor, not the sperm, because you get 250 million of those every time. So that's usually not the rate limiting factor, it's the eggs. But if you had twins, see Meredith, we were going somewhere with this. One of them you could, I don't know, do whatever you want with it. The other one, we could put it in some kind of controlled environment and we can compare them later over time. I think that'd be a fun study.
The world needs more twin studies.
It does need more twin studies. It's not going to get more twin studies. I should tell you why. Twin studies are really awesome, right? They're awesome because very rarely in humans do you get 2 people with the same DNA. Everybody's DNA is a little... Rats, you get rats with the same DNA all the time because you buy them out of a catalog. If you're doing... No, seriously, there are websites and vendors who sell you these sort of what we call inbred strains of rats, and they all have the same DNA, essentially, right? And they're all pretty much identical. Humans don't come that way. But if you ever luck upon getting a couple of you that are the same, anybody have an identical twin? Anybody know identical twins? Okay. So you know these identical... Are they on the roller derby team with you?
No, it's my dad and my uncle.
Oh, okay.
Yeah.
Yeah, they're identical twins. That's cool.
It's really confusing for the kid. But
Yeah. It'd be really confusing if you went on Maury Povich. Because there's... Please don't take this wrong. There's no way to know.
Yeah.
At least genetically, right? 'Cause there you go. So where was I going with this story? Twins, that we don't do twin studies as much anymore. So, you know, like your dad and your uncle, did they grow up together?
Yeah.
Yeah, so like who cares, right? I mean, they're both going to turn out pretty similar,
Yeah.
right? Because they had the same environment, they had the same DNA. What if we had taken one of those and they had grown up in Canada? They grew up in Canada, did they?
No.
Okay. And with some other parents, other than your grandparents. Well, that might have been interesting, because then we have the same DNA, but we have different environments. But there aren't a lot of people, volunteering to like ship one of their kids off. There's not like a twin exchange program, right?
But you would, wouldn't you?
Huh?
You would.
Yeah, I mean, we're not. I mean, this is how you know these things. The other thing is, the reason there used to be more twin studies is when there were sibling groups that needed adopted, they would split those sibling groups and kind of do single adoptions here and there. Now they tend to keep the sibling groups together. And so that may be better for the kids. I don't know. I don't know if they would ever know, right? If they're like this little infant, who's going to know, right? There's like one or two of you, you don't know. But we've lost that access as a scientific community because we don't have those kind of opportunities anymore. So try to have twins and start the twin exchange program. So if you all had twins at the same time, like, you wouldn't know, right? I mean, is it going to matter if it's really, I mean, a kid's a kid, right? You just swap them out. Same age, same gender, we'll be fine. You just say they're fraternal twins. So they're going to be identical. I thought more people would get on board with that. Because it was a good idea. All right. So genetic studies are actually kind of inconclusive, but they're interesting. They're inconclusive because there are a lot of genes that are going to influence serotonin function, right? So there are a lot of genes that are going to influence receptors, that are going to influence transporters, synthesis pathways, storage of the serotonin. Other related issues when we talk about the other, serotonin is not the only player here, right? Because we've talked about testosterone a little bit, right? So there are other things that are involved, and so it's kind of tricky to pull that out. You have to be very careful here, right? So you have to be, because you have to be very careful when you start talking about DNA and behavior, because people get a little touchy about that sometimes, right? And rightfully so in some cases, right? Because I don't know if you guys have heard of the like eugenics movements, right? Right. So I would reference the eugenics wars of the 1990s and see if anybody picked that one up, but don't think anybody's going to. So that was like a joke. So just let that one go. If you didn't get that, but that needs to be out there in the world. It does breed, and if you got it, if you on the internet later, type in the eugenics wars of the 1990s and see what you get. It'll be worth your time. Because you're going to get Ricardo Montalban. I think you're going to think Ricardo Montalban's worth your time. This is my so anyway. All right, Kate's already looking it up. No, it's okay. Keep doing whatever you're doing. No worries. So, actually, I was going to say like your grandmother might get more excited about Ricardo Montalban than you do. But that's the way things go. Anyway, eugenics was like not cool, right? So this was like, well, there are like defective people, and defective people shouldn't be able to breed, and you know, whatever. And then there was that guy Hitler. I don't know if you've heard of him. Yeah. So if you're ever going to write a book about like you shouldn't do eugenics, just bold letters, put Hitler on one page, front and back cover, and you're done, right? And there's your book, and you don't even really need to cite a reference, right? And that's the end of that. On the other hand, you also had these phrenologists. Do you guys remember phrenology? Yeah, that was a thing for a while. Like, if you had like a head that was lumped in one way or the other, that means you're funnier, that means you're whatever. Seriously, it's like you're smarter over here. Now, the problem with this was a lot of this stuff was, they did this, and they did it with like facial features and things. A lot of this came out of some guys from Italy who were like really down on Sicilians, and so they would like, oh well, if you've got like, if you've got Sicilian features, well, that means you're a criminal, right? And so they would sort of describe things that way. There's also a great, so who loves Mark Twain? All right, you're all going to fail. Mark Twain, not perhaps, is the greatest American writer of all time. Right, Amanda? I mean, that's just hands down. Whether you're reading Pudd'nhead Wilson, phenomenal. The Adventures of Huckleberry Finn, Connecticut Yankee and King Arthur's Court, even a great one, because there's like great economic lessons in there about inflation. So surprisingly great lessons. You should read these. He actually went to a phrenologist twice, the same one twice. He went once and told him it was a different name, and the guy's like, well, you've got a dry sense of humor, and you're like really boring, and you should be like a bookkeeper or whatever. And then he went back like 6 months later, and of course the guy forgot who he was, and he said, well, I'm Mark Twain. He's like, oh wow, I can tell because you have this prominent lump on this side of your head that you have a great sense of humor. And he was like, yeah, I was just here 6 months ago, and you told me that lump meant I was boring. So there you go. Phrenology, you got to kind of watch out for that. That was kind of sort of a related story, right, about this. But there are genetic sequences that probably influence your behavior on average one way or the other, right? I mean, if you have a more effective serotonin synthesis pathway, that probably means you're going to be less aggressive, right? Because you have more serotonin available. That just makes sense. And so you've got these receptors and other things going on. Questions about that?
What other foods are high in tryptophan?
Fried turkey, baked turkey. Shredded turkey, like sliced. Oh, you have an answer or you have a question?
I have a question.
Is it related to turkey?
No.
I've heard lettuce for some reason, but I don't know about that. But you can find that out.
That'd be correlated with turkey.
Yeah, I think so, right?
Yours says chocolate, oats, milk, yogurt, cheese.
So dairy products, yeah, cheese, yeah. This is why you have to be. This is why if you are on a monoamine oxidase inhibitor, an MAOI. So this is really, because I know how many of you go to these kinds of things. It's really, if you're on one of these, it's really going to like change your behavior. You can't go to wine and cheese parties because if you're on an MAOI, you're not supposed to eat wine or drink wine. You're not supposed to drink wine or eat cheese. So there you go. You still have your question?
I have two. One's a statement. I looked up the thing about the orgasms for you.
That was for Montana.
Well, Montana. It says that basically like the SSRIs change the sensation that you can feel.
Oh, that's disappointing.
Yeah. There you
What's
go.
one way to not make kids?
Yeah, but there are more fun ways to not make kids, right? That I think we should still. So that was your statement.
That was my statement. My question was.
And you couldn't answer the question by using the same website?
No. I just have one question. I don't know how this works, but could you use like for people who have like roid rage?
Sure, why not?
An SSRI, like
Yeah.
mellow them out or what?
So like in your car, we should have like a needle that comes out.
You fall asleep.
Oh, and then over on the other side, a little bit of cocaine. Just to get you back up.
I bet we could get that on 16th Street Road.
Are you saying something? Because I don't know if I told this class, but I had this moment of road rage. Like occasionally this happens to me. Like I'm probably on the irritable side of the scale of like irritable to not irritable. I don't have a whole lot of patience for those idiots who try to catch a monkey with their kids. And so did I tell this class about screaming at the old lady? Or was that my other class? I screamed really profane things at a very old lady once down on 3rd Avenue. And my wife was in the car, and she was like, why are you so upset? So I didn't know it was an old lady at the time. but there was a van in front of us, and there was an ambulance coming. So what do you do when there's an ambulance? You get out of the way, but the old lady, like, I couldn't see in the van, right? And she was like, not letting me get out of the way of the ambulance, like almost like intentionally, right? And I was like, there's an ambulance. So I finally get out of the way, right? Because the ambulance needs to go through, that's the rule. And then she like still is driving super slow in front of this ambulance, and the ambulance can't like get around her. I'm like, yeah. So I'm just like yelling things like at this person, and then the ambulance goes by, and so we drive on. The old lady had pulled into the what is it, like the Dr. Friday Simpson or whatever?
Yeah.
Is that the name of it?
It's called Dr. Fridays.
Yeah, Dr. Fridays. So, and she got out and had like a walker. It was like this really old woman. And I had yelled, I had made up things that were new. Like brand new words that you could use that you didn't know existed. And it just really, I don't know. So.
But her being old doesn't change the fact that she was driving like an idiot, so.
Right. And I thought, well, maybe she couldn't hear. And I thought, okay, so you can drive and be deaf. But you can't drive and be blind. And she should have been able to see in her rearview mirror flashing lights. And the sirens were going. I mean, like I could feel it in my car shaking. I don't know. So is that, yeah, so I think you could use it for road rage.
I said like a steroid, like
Oh.
roid. Right?
I think it's a road rage. I don't know. I mean, yeah, why not, right? I mean,
I just think that would be interesting.
so you can have a needle at the gym. You already have a needle at the gym. So you can, I don't usually recommend using the same needle, but if it's going in the same arm, I think you're fine. It would help. I don't know. I don't know that would. I wonder about that sometimes. Like, so I think there are a number of like roid rage cases that are in fact because I think they happen in like professional football players.
Yeah.
I think they're in fact CTE and not roid rage.
Yeah.
I don't know. I think there's some mixed evidence on that. And then of course you have to think about the mechanisms, right? Whatever those mean. Serotonin may or may not be able to overcome all other things. So does that help?
Yes.
So were you thinking about steroids?
Well, no, you were talking about all
Okay.
these other situations, and I was like, what about in this
Yeah.
instance? Some guy comes in swinging, doing steroids. What do you do?
Yeah. Shoot him with some serotonin.
There you
I guess.
go.
It's fine. I don't know. They should put like. Now I'm thinking like they should put. You could like wrap the weights with these like transdermal patches, right? So like whenever you grab the weight to like do your curls or something, you're gonna be like absorbing a little serotonin through there to kind of like. But I think that would get you to be like, you know,
Like break in case of emergency, serotonin.
like some guys getting too wild. I don't know.
It's not always guys.
No, it's not.
No, I worked at a gym for 4 years back home, and one of the like our worst like members was a female.
Really? Did you shoot her
Oh,
with
she was
serotonin?
mean. Like, she was.
You could just shoot her with serotonin and be fine.
I needed to.
Yeah. Like
Those
that.
dart
They
guns that
had.
they
Yeah.
try
Those
to
dart
get them to
guns.
use it.
Yeah, they've got those. They've got those dart guns. Meredith, you can get those next time you go to Winston.
Yeah, I'll bring some
You
back.
still have family there? Do you still go there periodically?
I live in Winston.
Like currently, that's a long drive.
I live like on the town side of Winston.
Oh, okay. Yeah. I lived over near the main campus on Rinaldo Road.
So yeah, I live like on 50, old 52.
It wasn't the best neighborhood.
Yeah.
We lived. It was an interesting neighborhood sometimes, though.
It depends what part of Rinaldo Road you're at.
Yeah, well, I could probably tell you this. So there was an interesting sort of like when you would go down Rinaldo Road. So we were there during, except in 2012, like the 2012 election, and there was a clear shift in the signs that you would see on Rinaldo Road. There was it was very clear, like who supported one candidate and then who supported the next. Like you would just make a turn and you're like, I called it Romney Row because like it was like there was like one house on that road that had like an Obama sign and nobody else did. It was just sort of interesting to see that sort of geographical shift. I did not live in the Romney neighborhood. I didn't make that much money. I didn't make that much money, period. That's why I lived in the other neighborhood that wasn't as nice.
So like me at a movie theater.
Huh?
Me at a movie theater.
I almost got in a fight in that movie theater once. So we went to that movie theater. I know what one you're talking about, right? And then from then on, we went over to the...
Grand.
Yes. So from then on, we went to the Grand. But I went to the one... there one time, there was a guy like kicking my seat. So I asked him like stop, and then he like stood up and was like trying to fight me. I don't know why. And then my wife told me we had to leave. We got our money back, and then we never went back to that theater. So that's an aggressive story because I mean that was impulsive what he did, not me. I mean I'm just like don't kick my seat, right? Just kick my seat. So
He was looking for a fight.
I think he was. I
Yeah.
don't know what he was doing. I think it backfired because he was there with his girlfriend. I think she was really embarrassed.
Yeah.
So.
Maybe it was like with the crustaceans. He's like battling you.
I don't know. The Gray. That's the movie I was trying to watch with Liam Neeson. The Gray. And I still haven't seen it. I still have only seen the first 15 minutes of that movie. When they like fall out of an airplane. That's all I
That's the
remember.
most brutal plane crash scene ever.
Yeah, it was. I saw that. And then this guy like jumps up and tries to fight me. I didn't even get any Sour Patch Kids. It's just a bad experience all around. Any questions? Guys, have a great day.